Okay, so in this problem I'm going to show you how to solve a simple linear programming model. This is just to give you the idea of the concept and how the problem is set up. You basically got a shoe manufacturer that has 2 plants and 2 retail stores. The operations manager would like to determine how many units each plant should ship to each retail store. And here's the shipping costs right here in the middle. So from plant 1 to retail store 1, it's $2 per unit. From plant 1 to retail 2, you've got to spend $3 per unit. And for plant 2, it's $2.50 per unit to retail store 1 and $1.50 per unit to get to retail store 2 from plant 2. So each plant has these capacities, 300,000 for plant 1 and plant 2 has 500,000 units. Retail store 1 has a demand of 350,000 units and retail store 2 has a demand of 400,000 units. What's important to recognize here is that the total demand, which is 400,000 plus 350,000 equal to $750,000, is less than $800,000. So that's important, because if the demand was higher than the capacity, there would be no feasible solution, and that's called an unbalanced problem, and we would have to fix that, as I will show you maybe later on in this spreadsheet in a different video. But for this problem, we've got a problem that is feasible, whose solution is feasible. So we can answer the question, how many units should be shipped from each plant to each retail store to minimize shipping costs, and what is the total shipping cost? So the way you lay out the problem is you first of all lay out that table that was provided in the question over here to the right, and you just put that in as your inputs. Then you have to set up your decision variables. These decision variables have you laying out the problem similar to the way we did in the actual question, except you leave this middle part here blank. In there will go the units shipped from each plant to each retail store. Then what you have to do is you have to give it some formulas. Number one, you have to sum up the row. This will indicate the total amount shipped out of this plant 1. You've got to take that same formula and go down to plant 2 and get the total shipped out of plant 2. That's called sum out, and that has to be less than or equal to the individual capacities of each of those plants. 300,000 for plant 1, 500,000 for plant 2. The other formula you have to do is you have to go sum, and you have to add up all of the shipments to retail store 1, enter, and that must be greater than or equal to the demand that is required. And it's important for this to be greater than or equal to, because if you put less than or equal to, this being a minimization problem, Solver just won't ship anything out of any plant, and that would satisfy that constraint to minimize shipping costs. Well, you don't want that. You have to ship to satisfy demand, or else you won't make any money. So you do the same thing with this column, is you just sum up this column, everything going into retail 2. So that's called the sum in right here. And I'm going to put that right there instead. That's called sum in. So that must be greater than this one for retail store 2 must be greater than equal to 400,000, which is the demand for that particular retail store. Okay, the last thing you have to do is you have to calculate the minimum or the shipping costs for each solution. So you do that, you use sum product again, and you highlight all this as one array, multiplying all that by the amount shipped. Eventually press enter, and that gives you what your total shipping costs are. Okay, so now that you have this laid out, the next thing that you have to do is you have to go to data and then go to solver, and you can see how I laid this out. The first thing we have to do is we have to set D20 right here. The shipping costs must be minimized, so you've got to click on the minimum box by changing these cells right here, subject to these constraints. And I'm going to remove these so that you can see them created. Okay, so I'm going to add the first constraint, which is you have to take the sum out and make sure that is less than the capacities. Click on OK and check it just to make sure you got it right. F13 and 14 must be less than or equal to H13 and H14. And then for the next constraint, you need to click Add, and you need to make sure that the sum in is less than or equal to the demand row. Click on OK, and then just check that. So D15 and to E15 must be less than or equal to D17 to E17. That looks correct. Make sure that this checkbox is checked and that you've selected the simplex LP method. Click on Solve, and it said it found a solution. So we click on OK. And I think what I did was I made a mistake, which is fine because then you won't make it. See what I did here? For D15 to E15, for this constraint here, this should have been set to greater than or equal to. Otherwise it gave me a zero solution, like I said it would earlier. So we click on OK. And now we run Solver. Click on OK. And there you go. It told you that you need to ship 300,000 units from plant 1 to retail store 1. Ship 50,000 units from plant 2 to retail store 1. Don't ship any product from plant 1 to retail store 2, and that makes sense because the shipping cost is the highest for that one. And then the last one is you want to ship 400,000 units from plant 2 to retail store 2. The total minimum shipping cost is $1.3 million, and that's your solution to this problem. If you get stuck, then you can look at the solution right here, where I've given you all of the formulas and the solver cells as well. Good luck.